Set theory. Okay, so this notation here, when we write it like this, an element of, X is an element of the set A. This notation, 0 with the line through it, this is the empty set. This is the set that has no elements in it. And we talk about a subset, so there's a different notation for subset than there is for element of. So this is element of, and this is subset. So A is a subset of B, so this would be the set A. Here would be your set B. A is a subset of B if for every X that's in A, it's in B. All right, so let's make sure we've got the two definitions down. So the set 2 is a subset of the set that contains the elements 1, 2, 3. Number 2 is an element of the set that contains the numbers 1, 2, 3. And A is not a subset, that's how we say it. A is not a subset if there exists an element in A that is not in B. And this, of course, would be another situation. Okay, so let's go through and practice these. And proper subset. If A is a proper subset of B, then there is at least one element in B that is not in A. So right here, there's an element here in B that is not in A, so this is called a proper subset. All right, is 3 an element of the set that contains the numbers 1, 2, 3? Yes. Is 11 a subset of the set that contains the number 11? No. Is 11 an element of the set that contains the number 11? Yes. Is the set 11 a subset of the set that contains the number 11? Yes. Is the set 4 an element of the set that contains the numbers 3 and 4? No. So this would be an element of, if I had this as my set, this is an element that's inside. So the set 4 is not an element of that. Is the set 2 an element of this set? Yes. Is 1 a subset of the set that contains 1, 2, 3? Yes, it is. Is 1 an element of the set that contains 1? Yes. Is the set 1 an element of the set that contains the number 1? No. The number 1 is an element of the set that contains the number 1. Is the set 1 a subset of the set that contains the set 1? So no, actually the set 1 is an element of the set that contains the set 1 because it's inside. Is 1 an element? Oh, this is what exactly this is saying. Is 1 is an element, so this is true. And so is 11 a subset, set 11 a subset of the set that contains the number 11? Yes. Is the number 0 in the null set? No, nothing's in the null set. Is the null set an element of the set that contains the null set? Yes. Is the set with the null set an element of this set? No. And is the null set an element of the null set? No. All right, so what we're going to be doing in the next section is we're going to be proving that two sets are equal, and that means we need to show that A is a set of B, a subset of B, and B is a subset of A, and that gives us that they're equal. All right, so two sets are disjoint if I take the intersection and I get the null set. If I have n different sets and they're mutually disjoint, that means that anytime I take an intersection of any one of them, any two of them, there's nothing in common. So this would be 3 sets, A1, A2, A3, and if I took the intersection between A1 and A2, or A1 and A3, all combinations gives me the null set. So they're called mutually disjoint. So this is OR, A or B, what that means X is in A or X is in B. This is AND, X is in A and B means X is in A and X is in B. B minus A means it's in B, but it's not in A. This is called the relative complement. And if X is in A complement, that means it's not in A. All right, so let's play with these. So let's draw a little number line to find out what we have for the set A. So the set A goes from -3 all the way to 0. So that's A. And the set B is from 1, I meant to draw the 1, up to 4. And the set C is from 3 to 9, but not including 9. Okay, there's C. So if I take A intersect C, is there anything in common between these two sets? There is not, so that's the null set. So B complement. Okay, so how are we going to write this? So B complement would be the x's that are in the reals, such that, and that's what that sign is, such that. So I want the x's that are less than 1 or the x's that are bigger than 4. And this was supposed to be an open circle, so that should be bigger than or equal to 4. All right, A union B. So A and B together, that's going to give me the x's in the reals such that I'm going to have from -3 to 0, so -3 to 0, or 1 to 4. Because they have nothing in common, so I'm just putting them both down. So A union B complement. Okay, so I'm going to take A union B and then take the complement of that. So A union B complement will give me x's are going to be smaller. Let's see, x's in the element of reals, such that the x's are smaller than -3, or they're between 0 and 1, or the x's are bigger than or equal to 4.